In this animated video we are going to learn the working of domestic suction water pump, by literally going inside the pump and explore how different parts work together. We will first see how power is transmitted from motor to crankshaft that moves the piston. We will also see the working of bearings, oil seal and gland packing. We will disassemble the pump and go inside to take a close look at the different parts like plunger, valve plate etc. and explore how they perform their task. Finally we will learn the working of suction and discharge valves.
So, let's begin. First, we will see how powertrain works. When motor runs, the motor pulley starts rotating. The pulley belt transmits this rotation motion to crank pulley. We will explore this side in greater detail in just a bit. First we move towards the back side and remove the back cover and gasket. There is an oil filling hole above the crank chamber covered by a rubber cap. Through this hole, oil can be filled inside the crank chamber for lubrication. Now, let's go back to crank pulley side. Then, we remove crank pulley and belt. After that, we can take out the side flange. Here, you can see a bearing that supports the crankshaft followed by an oil seal that prevents the oil from leaking out of the crank chamber. Also notice that there is a gasket too. Have a look at the inside of the flange. Here we can see the oil seal seat and bearing seat and also the gasket seating surface. Now we reassemble this side. Then let's move towards the crank chamber and observe its inside closely. When crankshaft rotates, through connecting rod, this rotation motion is converted to reciprocating motion of piston. Con rod is connected to piston via piston pin. There is a bearing between con rod and crankshaft to reduce friction between them because they move relative to each other. Also notice the oil bath bearing are also present at both ends to support the crankshaft. When con rod and crankshaft rotate, they splashes oil all around the crank chamber for lubrication of bearings and other moving parts. Now we put back the back cover and gasket and move to the center of the pump to understand what is happening there. Here you can see the portion of piston rod that is out of the piston chamber. To keep the oil inside, an oil seal is installed over the piston rod. You can observe the gap between piston rod and piston chamber. Oil seal prevents the oil leaking from this gap. Now we enter inside the piston chamber from this gap. For in-depth understanding of what is going on here, we first make our piston transparent to see through it. First observe the back side of the piston attached with con rod via piston pin and crank chamber that we have just explored a few minutes earlier. On the front side of the piston rod is attached to a piston via threads. Now let's turn back the piston to its original state and then make the piston rod transparent to see the threads on the front face of piston. Here you can also observe the inner surface of cylinder that guides the piston and in which the piston reciprocates. On the other side, through that hole from which piston rod crosses the piston chamber, you can see the same oil seal that we have just witnessed a bit earlier from the outside of the pump. Now we go back outside and fit the oil seal back to its housing. Let's move to that part of the pump from where the water pumping actually takes place. First we disassemble the pump to understand thoroughly the parts installed inside. On the very top, there is tank. Then there is a gasket between tank and valve plate. Similarly there is also a gasket between pumping chambers and valve plate. A sleeve that acts as a cylinder is installed via threads between the pumping chambers in which plunger moves back and forth to increase or decrease the water pressure inside the chambers. When plunger moves forward, it increases water pressure of the front chamber. At the same time, the volume of the back chamber increases due to which water pressure in the chamber is reduced and a suction effect is created. Similarly when plunges moves backward, the pressure in back chamber increases while pressure of front chamber decreases. If we see the valve plate closely, we will notice that the bottom side of valve plate is designed to match the pumping chambers. Therefore the front two valves are suction and discharge valves for front pumping chamber and two backside valves are suction and discharge valves of rear chamber. However the top side of the valve plate is different than the bottom side. Here partition is not according to pumping chamber but the partition is according to suction and discharge side. That is the partitioning is according to the tank above. Now we reassemble the pump. We then take out the front flange to get inside. Right in front of us, there is a sleeve in which plunger is present. In left side, there is a discharge valve and in right side, there is a suction valve. When plunger moves forward, the pressure is increased inside the pumping chamber in which we are present right now. This high pressure acts on suction valve and close it more tightly. This same high pressure also acts on discharge valve and work against the spring force to open it. The gap you are seeing right now allows the water to flow out of pumping chamber and into this discharge portion of tank from where it can leave easily through discharge nozzle. But if you observe the rear pumping chamber discharge valve, you will find it closed because and also you can see here that plunger is currently in the front pumping chamber, due to which the volume of the rear pumping chamber is increased, cause pressure to drop and suction effect is created. This suction effect is pulling down this valve to close it more tightly on its seat and maintain a good watertight seal. Now if plunger moves backward, things happen in reverse. Now the pressure in rear pumping chamber increases that causes the rear discharge valve to open. The front pumping chamber is now at low pressure. This low pressure along with spring force, closes the front discharge valve. Let's return the plunger to its position where it was before so that we can study the working of suction valves. Now if plunger moves backward, as we know the volume increases in this pumping chamber, generates a suction effect, that closes the discharge valve even more tightly. And this same suction effect work against spring force and opens this valve, so that water can flow from the suction portion of tank above to this pumping chamber. During this time the rear suction valve remain closed because the plunger is exerting pressure there. If now the plunger moves forward again, reverse happen, pressure in backdrops causes rear suction valve to open against spring force, and allow the water to flow and fill the rear chamber. And since the plunger is again back in front chamber and generates a high pressure there, that causes the front suction valve to remain shut tightly. Now in the last, we see the working of gland packing system, that prevents the water leakage out of pumping chambers. Here a water seal just like an oil seal, is installed over piston rod and inside gland housing. The remaining gland system works from the other side, that is from the outside of the pumping chambers. First we unscrew the gland nut out of the gland housing. After that we take out the 3 gland rings, and a water seal from inside of the gland housing. Now we put them back into their housing. After that we tighten the gland nut.